We're about ready to begin. Thank you all for coming. This is a panel on the use of the SIMIODE textbook with a typo in it, as you can see right there in the middle, although tech was used to produce it, so maybe it's an intentional typo. This is an unabashed promotional session to talk about the textbook that Kurt Bryan has authored. And the panel consists of me as a moderator, Brian Winkel. Kurt Bryan is the editor, who's an emeritus. AJ is from Florida Polytech. Wandy is from Middle Tennessee. David is from Goshen College, and Kate is out there in Flagstaff, Arizona. The purpose is to look from various institutions, have people discuss there, and maybe their students' uses or likes and dislikes about this textbook. I'm going to just talk a little bit about the textbook and its current offering, turn it over to Kurt, who'll talk about the evolution of this and the nice features in the current HTML version. Then I'm going to ask each of the four guests to talk about their uses of it, or anything they wish to share about why they thought they would adopt it, and hopefully no regrets, but maybe some suggestions. And then we'll have open discussion for people about topics or uses and so forth. So here's the cover of the text that Kurt Bryan has authored. The reviews we got early on were very favorable, and we haven't gotten any bad reviews. But the one I highlight, if you want to study the mathematics of differential equations in a modeling context, you're in the right place. That's reassuring from University of Nebraska. And this was a recent last summer review in the notices of the American Math Society. It said, if you want to refresh your undergraduate differential equations course and focus on modeling, this is a great book to consider. We're grateful to those reviewers. Here's some of the details. Namely, the current version is available in HTML. We've moved through a number of issues. We purchased about 500 paperback copies, and students weren't jumping up and down to buy those. So we wound up sending out a lot as desk copies to people and some people. And so now it exists not as just a plain PDF, but as an HTML file, interactive, and Kurt will talk about that, behind a group inside SIMIODE. Frankly, when we sold the PDF, a lot of students just passed the PDF around amongst friends. I understand the economic issues and pressures, but in this case, the HTML is behind what we call a paywall, and students have to join that group, and we want to have a little more activity and interaction amongst faculty who are using it and students, and we're building that as we speak. It's currently sold for $39 US as a part of our mission to support teaching differential equations in a modeling first approach and to help sustain SIMIODE common community of practice. There are costs incurred with SIMIODE. As the director, I draw no stipend or salary, but in future, when I hand this off to hopefully someone, we would generate enough funds so that the younger faculty could get some release time or support that way. The purchase of the text comes free with lifetime access to all future electronic versions, and we've had people take advantage of that already. They had purchased a PDF, we went to the HTML, and they went, hey, you promised me lifetime, and I said, you got it. And so people are using it for several generations of the text. And we're planning a print on demand later this spring, which may be of use to some people. And I thought maybe only older profs would like a print on demand. Turns out some students like that. They still like to scribble in the margin the way some of us did when we were students, and highlighting and so forth. So we're very proud of our text. We're very pleased to have people using it and to have students engaging in modeling, because that's what we're trying to do and that's what Kurt's trying to do. And so I'm going to stop sharing and do Ed McMahon, and now here's Kurt. Okay.
Okay. I'll start sharing my screen. I assume everyone can hear me?
Yes.
Excellent. let me share my screen. Let's see, what do I want to share? I think I'll share these slides. So I just have a couple slides, then I'll show you the HTML version of the text. But Brian came to me, oh my God, 5 years ago, and asked if I would, because we had taught together at Rose-Hulman, and he asked if I would write a textbook that focused on sort of the SIMIODE philosophy of using modeling to teach differential equations, which is what I learned from him when I started teaching at Rose. And I said, not knowing that COVID was only a month away, I said, yeah, what the heck, I'm not busy. And then, so I started writing it. And the idea is to use modeling and applications of ODEs just right up front to explain to students why the subject is important. So they have something to hook onto that makes them care. Most of the students at Rose-Hulman are undergraduate engineering students, and a lot of science students, and they want to know why are ODEs important. So by kicking off each section in an ODE course with an application, it gives them something to hang on to. And the way I structure the course when I've taught it, even before I wrote this book, was I always start off with an application. I say, look, we've derived this model, but we've got equations we don't know how to deal with. And we take some time, we learn some mathematics, and then we come back and visit the application again and say, oh, now we can figure out how the system behaves. After we can figure out the implications of our model. The goal is not to replace the mathematics entirely with modeling. It's just to provide a hook for students and a motivation to illuminate what the mathematics is good for, and to illuminate the mathematics. For example, the value of linearity in a model. If it's applicable, linearity is a godsend when you're trying to analyze models. And if it isn't appropriate, well, then you got to do something else. And I over the years, I've worked in industry, in academia. I worked in government at NASA. And there are certain topics that were always extremely valuable when I was doing differential equations. And one of them was, for example, dimensional analysis and the notion of scaling differential equations to illuminate what's important in the DE and what might not be important. So I integrated that material into the textbook. Parameter estimation, where frequently you have a model for a physical situation, but there are certain parameters that are unknown to you, and you have to estimate those parameters by taking data. And so I put in some material in the book on parameter estimation. Control theory, which I encountered in industry. Sometimes the whole point of modeling a physical system is so you can understand it well enough to steer it to a desired end. And so I put some material in on control theory. And then, of course, model assessment. Is this model any good? Compare it to data and make decisions. Now I put all those topics in, but I tried to structure the text so that you don't have to do any of it or any specific part. You can do an end run around any of those topics if you don't have the time. And let's face it, we all have finite time. The text I wrote with the original, I wrote in traditional LaTeX. Converted it to a PDF. We printed the book. We had a PDF file. Then we gravitated toward pretext, which is really a very nice system where, in principle, you write it in pretext. It's sort of like a markup HTML-like language, but with LaTeX mathematics as part of it. And in principle, from pretext, you can convert to HTML, you can convert it to LaTeX and make a PDF, you can convert it to an EPUB, you could make a Braille version of it. I haven't tried that yet, but I've tried the other three, and it seems to work pretty well. It incorporates a ton of modeling projects, many of them taken from SIMIODE modeling projects that are out there already on the SIMIODE website. Some of them, about a third to a half of them, I made custom for the book itself. Many of the projects include real data sets that are either available on the website or integrated into the text itself. And the text itself, one of the things I always found useful when I started writing stuff for students was incorporating little reading exercises along the way. As students read through, they're just little cursory checks of knowledge that they can do as part of the reading, where it's maybe it's a 10-second or a 5-minute exercise they can do as part of the reading, and then just to check their understanding and try to cement things as they go along. When more experienced scholars read stuff, you're usually scribbling stuff as you go and trying to work out simple examples as you go to fill out your understanding. But of course, it also includes the usual end of section exercises. It includes end of chapter modeling projects, and of course, complete sets of solutions are available to instructors. For students, there are the usual selected subset of exercise solutions available. And then there's, on the SIMIODE website, you can find all the data sets and a ton of supporting code that I wrote in Maple, Mathematica, MATLAB, and Sage. There's about 70 pieces of code there in each of those languages, each one parallel. The Sage is available as either just Sage code or Sage Math or Jupyter notebooks. So I tried to make it easy for students to get their hands on the data and start playing with it right away. Now, what I would like to do is just quickly show you what the textbook looks like in HTML. So here it is. This is I should tell you right now, this is my personal online copy of the textbook. So if you look at the top of the screen, you can see the URL that you could use to get free access to the textbook, but that URL will not be active in about an hour from now, so don't get any ideas. But here is the textbook and what it looks like in HTML. So here is what it looks like compiled to HTML from pretext. You can see the chapters. It looks very nice. Even by default, it looks pretty good. So you can, click on, it's all HTML, so it has exactly what you'd expect in HTML. It's hyperlinked, and let me just pop down to a typical, this is what it looks like. This is in the first chapter, a model of population. This is to kick off differential equations before the students know anything. It's a motivational application. The first chapter is devoted mostly to motivational applications. And you see, there's graphs in there. If you click on a graph, it'll enlarge it a little bit. That one doesn't enlarge much. But, it looks good. Everything is hyperlinked. So here's a reading exercise. You see, you click on it, and it expands. If you click on it again, it compresses it. This is a reading exercise students can do to check their knowledge. There are hints. You can expand the hint. And every reading exercise has the answer in the book, in the HTML text, but I don't display it by default because I don't want students to just look at it and read it and say, oh, yeah, I understand that. So it gives them a chance to think about it a little bit, but then when they decide, okay, I want to know how to do this, there's an answer there. They can click on the answer. Equations, for example, when you're scrolling through, if you see an equation, if you see equation 1.3.1, this is nice. You don't have to scroll back up and try to find that equation. If you just click on it, it just displays it in context, as they say. You can collapse it. And so there are numerous reading exercises, and I incorporated Sage Math code into the text. So in here, this is a cell containing Sage Math code. It lets the students experiment with the models and not have to be experts in programming in Sage. So you click on evaluate, and it will show you, it'll show you the result of a computation. It'll show you a graph. Students can say, okay, what would happen if I change the growth rate in this model to 2? Well, reevaluate it and see, what does it do? Oh, look, it grows faster. What if I change the carrying capacity to 30? What does the model do now? Oh, look, it goes to 30. So they can start experimenting with models right up front without being experts in Sage, although it'll help them learn Sage. So they can modify that in an obvious way. Of course, everything's hyperlinked, so and I threw in appendices on stuff I always have to teach students. Complex numbers. You want a refresher on complex numbers, or you could even consider this an introduction to complex numbers if you want. So, there's stuff on, how do you exponentiate complex numbers, that sort of thing. There's a whole appendix that's a basic treatment of matrix algebra. Because I love circuits, which so many mathematicians around here seem to be afraid of, I put in a nice thing on circuits, and I try to teach them, mechanical analogs of circuits to build their intuition if anybody's interested in circuits. So it covers all the stuff I've ever taught in DE, and it's HTML, so it's very interactive. So that's what the text looks like. So I'll stop sharing there and shut up.
Okay, thank you very much, Kurt. I should tell you that when Kurt first came to Rose-Hulman, I was a Tut senior faculty, and he was just this young but experienced whippersnapper, and he had a release time first position, and I said, how would you like to help me teach my section? What I was really saying is, how would you like to teach my section so I could be a slacker? And he foolishly agreed, so we taught together, and we decided to use modeling to motivate. And we'd work on some modeling activity, and the next day we'd go into class. And at the end of the semester on student evaluations, the student said, we knew when you were on, meaning doing modeling, and we knew when you were off, meaning lecture. And we didn't like it when you were off. And I think that's the first time we both knew we were on to something.
I remember there were days when we were just tired.
Yeah.
I can't think of any creative model, so let's just talk about
integrating
factors and your ODEs, and the students were like, okay, we'll take it, but we don't like it.
Yeah. And so we learned a lot about ourselves, about students and perspectives, and that has now, I think, paid off in this regard. So I'm going to go in order that I had there, and I apologize to Kate for being last, because I grew up with the ladies first. But at any rate, I had AJ on the list first. So from down in Florida, where all the sunshine is, supposedly, why don't you share your opinions and uses of the text? Thank you, Kurt.
Thank you again. Very good to see you, Kurt. Good to see everybody. So I do have a few slides. So we just started implementing. So we've been using Kurt's book for what, 2 years now? A bit over. I think we started using it as soon as it came public. We loved it. I personally loved it. Because I had to always adapt the way I teach differential equations to, okay, let me introduce and the book does it for me. So it saves me a lot of time. It also has a lot of really creative models, so I don't have to dig up myself. It saves me a lot of time. So I can actually focus on discussion of the model, how to build it. So it was very interesting for me. We recently switched to the online version of the book as well. And I did actually start poking around all the faculty who taught the course over the past year and a half almost, but particularly the ones who've used the HTML to get some feedback from them. So if I can figure out how to share my screen. Okay, so I want to share this one. Okay. So hopefully you all can see my screen. Let's move this here. All right. So just a few slides of feedback, and it's nothing really fancy. Come on, move. Oh, why is it not moving? Oh, there we go. Okay, there we go. So the general consensus is both students and faculty really like the book. Some of the comments that I got were people just walking into the classroom, pulling up the book on the classroom computer and just projecting the book, as opposed to doing like writing stuff on the board or getting their own slides in there. They're actually just using the book as a presentation tool. The book is nicely written and very well organized. That it really works as a presentation tool. You don't really have to supplement it with slides, or it's really very nicely written. And a lot of people said that they really like the drop-down options for the solutions. They want the students to kind of think about it a little bit. Now, some of the students can pull up the book on their own phones and devices, but a lot of them do participate and actually try before they look at the drop-down menu, so that's helpful. The hyperlinks, people love that. It's been very, very useful. The majority of people just are kind of going through using the hyperlinks just instead of flipping through the pages or the scrolling through the PDF. They feel that versus the PDF version, which you can also use and present on the board, they feel that the sections, the way they're written on the web page, they're much more manageable. So if you want to cover a section in a day, it's much more manageable the way it's organized on the HTML version. Going from the textbook or the PDF to the HTML was very easy, quite seamless. There is a shift in the so if you assign homework from the book, some of the homework problems have been shuffled around a little bit, which is not a bad thing. There is interest in or possible interest in this question that came to me multiple times from multiple faculty. Can we add something on boundary value problems early on? I think I don't remember exactly off the top of my head, but I think you get to boundary value problems towards later on when you get to the PDEs. But some people want to see boundary value problems very early on in the class. So and they feel like they have to supplement that on their own, and they're figuring that the material that they're producing is not. So the students feel this disconnect if they talk about boundary value problems on their own. But a lot of students get differential equations and then maybe a semester or a year after sign up for PDEs, and they end up not remembering or not knowing BVPs at all. So that was a feedback that I think was valuable. From a student's point of view, students loved the book. I think this was one of the comments from students. It was interesting to use differential equations to model real-life phenomena. That was actually students wrote that. So we have labs designed to use material from the book. The labs were MATLAB based. Students loved the labs. They felt like they're very useful, but they had struggled with the coding. Even though we don't really assume they know how to code with anything, that we teach all of that from scratch. We did notice that there is let's see, what was it? Let's move this here. Oh, the class average right now is averaging about 85% on assessments. So, and by the way, we actually did before and after assessments. So we used similar exams to what we used in the past before we switched to the modeling first approach. And we went from an average 70 on a good semester to an average 85%. I mean, if you look at the trends of the classes, there's a definitely positive trend tending toward we're actually thinking of how to make the exams harder now. So it's when you start talking to faculty, it's like, okay, well, the students are doing too well. It's like that's kind of our problem right now. Overall, everybody. And the integration of Sage, what you talked about, Kurt, was especially because Sage is very close to MATLAB. I think from a faculty point of view, they love it. Students are introduced to Sage and they are getting to use it, so that's really good. Overall, everybody is incredibly pleased with the book. So that's kind of the feedback I managed to gather from faculty and from students.
Thank you very much, AJ. We've enjoyed working on this project, and I'm so glad that you enjoy using it with your students. Thank you all very much.
Thanks, everyone.
And take care.
Thank you.
Email me if you have any suggestions.
Yes, by all means. Take care.
Thank you so much.
Thanks.